In this lecture, we evaluate the limit 1 minus x to the power x whole divided by x log x when x tending to 0. We have to evaluate L equal to limit of 1 minus x to the power x upon x log x when x tending to 0. Now here, if we substitute the limit, we are getting first a 0 to the power 0 form. Second, if we are putting x 0 here, it is 0 into infinity form. So clearly, if you want to evaluate this limit, we have to first find what is the value of x to the power x when extending to 0 and what is the value of x log x when extending to 0. Therefore, we have to first evaluate limit of extending x to the power x when extending to 0 and limit of x log x when extending to 0. Let m is equal to x to the power limit of x to the power x when extending to 0. Now if you put x equal to 0, it is nothing but 0 by 0 form. And we know that if the any limit has 0 to the power 0 form, we have to apply or we have to take log on both the sides. Taking log on both the sides, we have log of m equal to log x to the power x. Again, we know that log m to the power n is m log n. So we can write down log limit of x log x when extending to 0. It has the form 0 into infinity form. Now, if we want to find out its value, we will use the L'Hospital rule. But if it is in the form of 0 into infinity, we are not able to use the L'Hospital rule. For this purpose, we have to convert this into the form of either 0 by 0 form or infinity by infinity form. So can we write like that? Log x in the numerator and x can be written as 1 upon x because this x goes to numerator and multiply with this. So x log x can be written as log of x divided by 1 by x. Now, if you put the limit log of 0 is infinity, 1 upon 0 is infinity, so it has infinity by infinity form. Now we can apply the L'Hospital rule. Applying L'Hospital rule, we have to differentiate numerator as well as denominator separately. Derivative of log x is, let me go ahead. Derivative of log x is 1 upon x and derivative of 1 upon x is nothing but minus 1 upon x square. 1x and x will cancel. This x goes to numerator and we have minus limit of 1 upon x into x square upon 1 when extending to 0. 1x will cancel. We have minus limit of x when extending to 0. If we put the limit, we are getting its value is 0. It means that limit of m log, which means that limit of x log x, which is equal to 0 when extending to 0. Now, since log of m equal to 0, so what is the value of m? We have to take anti-log on both the sides. It will become, since its value is 0, it is e to the power 0 and e to the power 0 is 1. So m is equal to limit of x to the power x when extending to 0 is nothing but 1. Now let us come to our first part. L equal to a limit of 1 minus x to the power x, x log x when extending to 0. Now, since we know that x to the power x when extending to 0, it is 0, and it is 1, and x log x when extending to 0, it is 0. Therefore, numerator becomes 1 minus 1 is 0, and denominator also becomes 0. It is 0 by 0 form. Since it is 0 by 0 form, then we can apply L'Hospital rule. So applying L'Hospital rule, we have derivative of 1 minus x to the power x divided by derivative of log x, x log x. Now derivative of 1 is 0 and derivative of x log x to the power x. How to find the derivative of this? So let me write down. Suppose we take L equal to x log x. If we take log on both sides, log of L, which is equal to x log x. Now if we differentiate it, 1 upon L dl upon dx, which is equal to x derivative of 1 upon log x is 1 upon x plus derivative of x is 1 into log x. Now this x will cancel. Derivative of L with respect to x, which is equal to L times of 1 plus log x. And this L is nothing but x to the power x, 1 plus log x. So clearly, this is what x to the derivative of x to the power x is minus x to the power x into 1 plus log x. And in the same manner, in the denominator, first function, derivative of log x is 1 upon x plus derivative of x is 1 into log x. Again, this x will cancel and we have minus, we can take outside this minus x to the power x, 1 plus log x divided by 1 plus log x. So these two will cancel. We have minus limit x to the power x when extending to 0. And we know that what is the value of x to the power x when extending to 0 is nothing but 1. Therefore, L is equal to minus 1. Therefore, limit of 1 minus x to the power x upon x log x when extending to 0 is nothing but minus 1. Thank you.